a few more examples of being able to find the derivative of a function using our techniques of differentiation. So we have this 8x cubed minus 37x plus e to the fifth. All right, so what we're going to do is we're going to go back and we're going to remember some of the rules that we had. All right, so let's go back up here. Now, one of the rules that we remember is that if we have a sum and difference, we just take the derivative of each function individually. All right, or each term within that polynomial or that expression. Another rule that we have to remember is that if we have a constant times an x, the derivative is just the constant. We have this rule where a constant times x to the nth power is x to the n minus 1 times c times n. And then finally, this is a rule that's kind of sneaky that we have to use. And most of you are probably thinking, okay, well, I see an e to the fifth in there, all right? But we're not going to use this rule, e to the x, all right? So when we take the derivative, we're going to say that this is going to be equal to, so this is f prime of x, that's going to be equal to 8 times 3 times x to the 3 minus 1 minus 37, all right? So remember, we're just doing these term by term. And then finally, e to the fifth is a constant. It is not e to the x or e to the 5x or anything like that. So that's just a constant, and we know that the derivative of a constant is 0. All right, so be careful with that. Anytime a term does not have an x or a variable in it, it's a constant, so its derivative is 0. So our derivative, in its most simple form, is going to be 24x squared minus 37. All right, so just be careful with that whenever you start to see some of these rules. All right, this isn't one that was in my math lab. However, it's an important problem for everybody to understand the technique to be able to find the derivative of this sort of rational function. So we have a function 1 over x squared plus 1 over root x, and we want to find the derivative. All right, so to be able to find the derivative, we actually have to prepare this for differentiation. And to do that, to prepare it for differentiation, what we're going to do is we are not going to find the derivative yet. We are just going to rewrite the function. One of the things that we can do is we can rewrite 1 over x root as 1 over x to the 1/2. All right, so this would be 1 over x squared plus 1 over x to the 1/2. Another thing that we can do is we can take those exponents out of the denominator, and we can rewrite those as x to the minus 2. And then x to the minus 1/2, right? Now the ones are still there, all right? So it's really 1 times and 1 times that, all right? But we know that 1 is implicitly an identity, so we don't multiply by that. Now we can find the derivative by using our derivative rules. And so f prime of x, all right? So think of this as the 1, all right? So we're going to have 1 times negative 2 times x to the negative 2 minus 1 plus 1 times minus 1/2 times x to the minus 1/2 minus 1. Right? So that's our rule. We're going to clean this up. We know 1 times negative 2 is negative 2. Negative 2 minus 1 is negative 3. 1 times negative 1/2 is negative 1/2. Negative 1/2 minus 1 is minus 3/2. You might remember in pre-calculus that for some reason, we don't want to write things with negative exponents, so we're going to get rid of the negative exponents. So we can write this as minus 2 over x to the 3rd. Now notice that 2 does not have a negative exponent, so it stays in the numerator. To rewrite the second term, that's going to be negative 1 over 2, because the 2 is already in the denominator, x to the positive 3/2. Okay, so this is all just algebra at this point. And then finally, the last thing we can do is the 3/2 power. We can turn that back into a square root function. So the final answer that we should try to write this in, negative 2 over x cubed minus 1 over 2 square roots of x cubed. All right, so notice that the 2 becomes the square root, and then the 3 just kind of stays as an exponent. All right, so that's our derivative of that function. Right? Really nice and easy to find the derivative compared to using the definition of derivative, which would be very painful. So Be careful with that, where you have to prepare these functions for differentiation sometimes, especially square roots and when you have just singular x terms in the denominator. All right, now if that's x squared plus 1, that's what we're going to do in the next chapter. All right, so an old concept, equation of a tangent line. All right, so let's go through and see if we can find the equation of a tangent line and then use a graphing utility to graph the curve on a tangent line in the same set of axes. All right, so we have this function. We have y equals x cubed minus 7x squared plus 5x minus 4 when a is equal to 1. And so we're going to find the derivative. We're going to find the equation of the tangent line and solve it for y. All right, so to be able to find the equation of the tangent line, first thing we're going to do, let's just rewrite this as f at x instead of y. Not that we have to, but we can. So x cubed minus 7x squared plus 5x minus 4. And usually we're given a point, right? Usually we're given like an x1, y1, but we're not given that this time, right? What are we given? We're just given that a is equal to 1. So what we can do is we can just substitute 1 back into the function to get the y value. So that's going to be 1 cubed minus 7 times 1 squared plus 5 times 1 minus 4. And if we compute that, that should be equal to negative 6. All right, because we're going to have 1 minus 7, which is negative 6, plus 5 is negative 1. So maybe it's negative 5. Let me check that one last time just to make sure. Negative 11 and 6. Yeah, that's negative 5. All right, so good thing I checked that. Otherwise, we would have done the whole problem and it would have been wrong. All right, so now remember, this is the y value. So this is y1. All right, so the point that we're looking at is 1, negative 5. And of course, at the end of the problem, when we graph it, we'll know if we're correct or not because it should be tangent at that point, not secant. Now we're going to find the derivative. Let me get rid of this so we have enough room to work. So now we're going to find our derivative. Our point was 1, negative 5. F prime at x is going to be equal. We're just going to use all the derivative rules. So we have 1 times 3 times x to the 3 minus 1 minus 7 times 2 to the x to the 2 minus 1 plus 5, because remember the derivative of 5x is just going to be the coefficient 5. And then since 4 doesn't have any x's in it, it's a constant. The derivative of a constant is 0. So our derivative in its simplified form is going to be 3x squared minus 14x plus 5. Right, so hopefully that makes sense. Really easy to find the derivative, much easier than using the limit definition. Now we have to find the derivative, f prime, at 1, because that's going to tell us what the slope is when x is equal to 1, or in this case, a is equal to 1. All right, so let's go through, sorry. I'm just going to give myself a little bit more room here so we can finish this. So f at 1 is going to end up being 3, or f prime at 1, 3 times negative 1 squared, 14 times 1 plus 5, which should work out to be negative 6. 3 minus 14 is going to be negative 11. Negative 11 plus 5 is negative 6. And remember, this is the slope at that point, a equals 1. Right? So we have our slope. And at this point, we remember that the point that we were looking at was 1, negative 5 on the function. And let's just go through and finish this off. We have our formula, y minus y1 equals mx minus x1. So we're going to get y minus a negative 5, because that's our y1. We have our slope, which is negative 6, and we have x minus 1, which is our x1. So we end up with this function, y plus 5, excuse me. So we have y plus 5, and we're going to distribute the negative 6. So we get negative 6x plus 6. We subtract 5 from both sides. And we end up with the equation y equals negative 6x plus 1. All right, or we hope. And that's the answer to part A. All right, so if we go all the way back, remember, find the equation of the tangent line when A is equal to 1. All right, so now, how do we know we're right? Or how do we check if we're not correct? What we can do at this point is we can go through and just try to find what our graph looks like. All right, so we're going to go back, and I might have to switch back and forth because the function's kind of long. So we're going to graph. I'm going to clear this, and I'm going to clear this. So we're going to have x cubed. So we have our x cubed minus 7x squared. And then I think it was 3x or 5x or something like that. Let me go back and check. 5x minus 4. And I need a plus in there, so plus 5x minus 4. And then remember we had our function, which was negative 6x plus 1. That was our tangent line. All right, now let's graph it, and let's hope that we're going to get through and get a tangent line. Now remember, in one of the previous problems, I zoomed in a lot, so I'm going to zoom standard. All right, so this looks like a mess, doesn't it? Let's zoom out a little bit. So let's zoom out. Again. All right. It actually looks like it's pretty good. One of the things we can always do is we can trace the function, or we're tracing it to 1. All right, so 0.85 is pretty close to 1. I'm going to zoom in there. All right, so we have our tangent line. All right, usually in my math lab, it'll tell you a window or something like that, so you might just want to use the window. I'm going to trace it a little bit more, and 1.06 is pretty good. I'm going to zoom in again. And remember, if the line is tangent, it kind of melds into that function. So let's just go ahead, zoom in one more time. And it looks like it actually does exactly that. I could trace it to 1. 1.01 is really close. So let's just zoom in one more time. And it should look like that the cubic and the linear functions just become the same thing. And in fact, it does. So that's how you can kind of check to make sure your answer is correct. However, remember, the original suggestion was just to graph it and then see if the point, what the graph might look like. All right, so hopefully this makes sense when you go to put your answer into my math lab. All right, so those are our techniques of differentiation, at least the most elementary types. All right, so now what happens when we start having functions being multiplied? All right, so we haven't seen what happens if we have something like f of x equals x squared sine x, or even like a rational function like x squared plus 1 over e to the x minus 1. All right, so those are going to be our final types of basic derivatives, which we're going to look at in the next chapter, 3.4. We start talking about something called a product rule and something called a quotient rule.